Now that you've had a chance to work on the formal definition of the derivative using limits, we are going to explore some of the shortcut rules today to make that process a lot quicker. Hopefully you already had a chance to look at the shortcut sheet. And when comparing, had a chance to notice that the exponent, especially on the first two, it's really easy to see that the exponent is coming in front. And then the other part that's important is that the exponent is going down by 1. The best place to see that is here, between the x cubed and the 3x squared. So the cubed becomes a 3 in front, and then decreases by 1 and becomes a squared here. All of the other ones were squared, and then became 1 as your exponent. So those are the two components that are important for the power rule. So we're now going to give a formal definition and then take a look at some examples. So for the power rule, it states if n is any real number and f of x is equal to x to the n, then f prime of x is equal to, I'm just going to highlight the n here, n, so the exponent now becomes the coefficient, or you're multiplying by the front, x to the n minus 1. And the n minus 1 is just telling you to take 1 away from the original exponent. We also have an alternate notation. Instead of f prime of x, we can say d over dx of x to the n is equal to nx to the n minus 1. And this notation, the d over dx, just means take the derivative with respect to x. And the difference is you're putting it in front of the function that you're finding the derivative of, rather than defining it using the function notation. But it's pretty much the same thing. So let's take a look at a few examples. My first example, f of x is equal to x to the fourth. So nice, easy one to start off with. If we were doing that with the limit notation, it would be a lot of work because you'd be expanding out something to the fourth. Here, we bring the 4 in front, so it'll become 4x. There wasn't anything to multiply by because there was just a 1 in front. And then we'll subtract by 1 for the exponent, so it will become 4x cubed. And that would be your derivative. Our second one is going to involve translating over into an exponent. We're going to start with square root of x. So before I even take the derivative, I'm going to rewrite the square root of x as an exponent. So we have to reach back for those exponent rules. Square root of x is the same as x to the 1/2. Now we'll take the derivative. And there's two parts to this. We'll bring the exponent in front. And then you have to think about if I take 1/2 and subtract 1, 1 over 1 would be the same thing as saying 2 over 2. So we'll end up getting a negative 1/2 as our exponent. And then anytime you have negative exponents, we just want to bring them to the bottom of a fraction. So we're going to make this 1 over 2 x to the positive 1/2. And that would be our final derivative. Next one will also have a fraction exponent where we'll start with a fraction. So same idea, f prime of x. This will become 2/3 x to the, again, we're going to subtract 1, so 2/3 minus 3 over 3 is going to give us a negative 1/3. And in order to keep all of our fraction exponents, we'll make this 2 over 3x to the 1/3. just a few more examples for this section so we can see a couple other things happening. So now I have I'm starting out, instead of moving the exponent to the denominator, it's already there. So just like I rewrote my radical one, I want to rewrite this with the negative exponent to start with. Get it out of the fraction. Then we'll take the derivative and we can put it back into fraction form after. So we'll bring the -3 in front. And then be careful with your subtraction. We're doing -3 minus 1 to get our exponent, so we'll be to the -4. And then again, we'll make this into a fraction, so I'll keep the -3 on top, only move the x to the -4 down to the bottom and make it positive. And then our last two are just some special case ones. If I have f of x is equal to x, the derivative, we're going to bring down the 1 in front. But then it's really x to the 0, because if we subtract 1 from that exponent, x to the 0 is equal to 1. So we're not going to put a variable with that. Anytime you have x to the first, you bring that coefficient in front, whatever it is, or x squared, not x squared, x to the first, or if it was 2x to the first, 3x to the first, you bring the number in front and then the variable goes away. And then if you have a number where there's no exponent, like the last one in this section, that derivative is going to be 0. And if you looked back at some of the original examples, any of the numbers that were in there without a variable just kind of disappeared and weren't part of your answer. All right, I'm going to end this first video here. We're going to look at a second video for the constant multiple rule and for sum and difference rule, where we're adding, subtracting different parts together.